Hi everyone, you're watching the Laws of Exponents notes video. In this video, we are going to talk about maybe some things that are review, maybe some things that are new. But before we start going deeper into the polynomials unit, we really need to understand how exponents work. So let's dive in. First thing that we want to do is be able to identify what the vocabulary is. We're going to evaluate exponents, and then we're going to use the laws of exponents today to kind of simplify and evaluate problems. Okay, so this whole thing of like a number raised to a power or an exponent is called a power. So the base is the bottom number and the exponent is the number up top. And what an exponent does is it means take that number at the bottom and multiply it by itself 4 times or however many times. I'm looking at example number 1 here, and that's why I had said 4. So when I see 2 to the 4th power, to me that just means 2 times 2 times 2 times 2, which is 2 to the, 2 times 2 is 4, times 2 is 8, times 2 is 16. Okay, that is how we will find our answer for 5 to the 3rd power. That's 5 times 5 times 5. So 5 times 5 is 25, times another 5 is 125. Negatives you need to be a little careful with because that's negative 3 times negative 3 times negative 3. So negative 3 times negative 3 is a positive 9, times another negative 3 is a negative 27. 7 to the 1st power, well, you guessed it, it's just 7. So any number raised to the 1st power is just itself. This is where things can get a little tricky. Any number raised to the 0 power is actually 1. So that's a rule that you will just want to remember. There's a reason behind it. We're just not going to get into it today. All right, moving on to the next section, rewriting using a single exponent when we have the same base. So see how we have 2 to the 4th times 2 to the 3rd? Well, 2 to the 4th power is 2 times 2 times 2 times 2, times 2 to the 3rd power is 2 times 2 times 2. If we write this as a single exponent, this is really 2 to the 1, 2, 3, 4, 5, 6, 7th power. So how did we get that? What did we do between 4 and 3? We added them. You are right. 4 plus 3 is 7. So we can generalize this rule. X squared, oops, sorry that my screen keeps jumping around today. X squared times x to the 7th would be x to the, well, we're just going to add them together. You can expand it out. I don't think that we need to do it, but you could if you wanted to. 2 plus 7 is 9. All right, let's generalize it for number 8. Notice again how we have the same base. That's why we are allowed to do this. And we are adding the powers. So 3 to the, 2x plus 3, that's not 5x. I can't add apples and bananas to make banapples. So we would just have to write that as 3 to the 2x plus 3rd power. I know it looks weird, but that's how it's going to go. Can't group them together. All right, powers raised to another exponent. So 5 to the 3rd, all raised to the 4th. So what this is telling us to do is take 5 to the 3rd and multiply that by itself 4 times. Well, this is just like adding exponents now, right? This is just like above because they all have the same base. And when we multiply, when they have the same base, we get to add the exponents. So this is going to equal 5 to the 3 plus 3 is 6, plus 3 is 9, plus 3 is 12. What is that rule? What did you do between 3 and 4 to get 12? You multiplied. That's cool. So let's do this with number 10. So x squared to the 5th power is actually x to the 2 times 5, which is 10th power. And then number 11, this looks a little weird. So again, let's generalize. 9 to the 8th power to the x power Well, we're just going to multiply 8 times x, which is 8x. We can multiply a number times a variable, and we're going to do that a lot this unit, actually. Okay, negative exponents. These are weird, but for now, we are just going to discuss, and actually we talked a little bit about this in the exponential unit when we were dealing with graphing exponential functions, but anytime we have a negative power, we write it as a positive power in a denominator. So see how I just flipped it? 6 to the negative fourth is 1 divided by 6 to the positive fourth. 8 to the negative third is 1 over 8 to the positive third. X to the negative seventh can be written as 1 over x to the positive seventh. Okay. Now, a little more fun with exponents. A couple of things that we wanted to point out is that there is a difference between this and this. And some of you might say, yeah, it's parentheses. Well, it's actually two different answers. 2x to the third power is just 2x to the third power. But 2x all raised to the third power is a little different because that's 2x times 2x times 2x, which is 2 times 2 times 2. Well, 2 times 2 is 4 times another 2 is, 8. X times x times x is x to the third. So parentheses matter. They're a big deal. And one last thing that I wanted to talk about, I think this is actually kind of a cool question. So we need to rewrite 3 to the 2x power using laws of exponents. Well, if you think about how did we get this, that's 2 times x. So if we were multiplying, that means we were dealing with power to a power. So this probably came from 3 squared all raised to the x power. It's like we're going backwards. And what's another way to write 3 squared? 3 squared, 3 times 3. So this could also be written as 9x. So I hope you had fun working with exponents. We are going to use these all over the place this unit, and this was just a really fun introduction just talking about some of the laws.